we will continue with Kirchoff's laws. Kirchoff's current law, or KCL, states the sum of all currents flowing into or out of a node must be equal to 0. That is, the sum of our currents flowing into a node must be equal to the sum of the currents flowing out of a node. For instance, consider we have node A. Into node A, we have I1. Out of node A, we have I2 and I3. The sum of our currents into our node is equal to I1, and the sum of the currents out of our node is equal to I2 plus I3. Therefore, mathematically, we can state I1 is equal to I2 plus I3. Kirchoff's current law is a continuity of charge carrier. That is, the quantity of charge carriers entering a node must be equal to the quantity of charge carriers exiting a node. That is to say, we cannot create nor destroy charge carriers within our system. Kirchoff's second law, that is, Kirchoff's voltage law, or KVL, states the sum of all voltages around a loop must be equal to 0. That is, the sum of our voltage drops must be equal to the sum of our voltage rises. We have seen this before when analyzing a simple circuit. Consider we have a voltage source that is connected to a resistor. As we have current flowing through our system, our current follows a loop. That is, as we increase the voltage potential going through our battery, we decrease our voltage potential going through our resistor, such that the net difference of our voltage potential increase and decrease is equal to 0. Kirchoff's voltage law states that we cannot have any unused potential within a loop.